Hello, Mr. Bainey here. Today's lesson is 2.4, Creating and Solving Inequalities, the essential question. How do you write and solve an inequality that represents a real-world situation? And the standard A point CED3 represent constraints by equations or inequalities and interpret solutions as viable options in a context. The first thing that should be reviewed is this inequality concept. So instead of writing equations and creating equations and solving them, we're going to be writing inequalities and solving them. Inequality, instead of using an equal sign, is going to use these symbols that are down here below. You should have had some experience with solving these, possibly even creating some in 7th grade. Let's take a look at some examples. And before we go on to page 75, I do want to mention that the main difference between an inequality and an equation is this statement right here underneath the distributive property box, making sure that the inequality sign is flipped or reversed when you're multiplying or dividing both sides by a negative number. Okay, so that inequality sign will flip when that happens. Let's take a look at an example on page 75. If you'd like to try any of these before you see the solution to them, feel free to pause it. I'm going to go in order here. Number 4, Zachary is planning to send a video game to each of his 2 brothers. If he buys the same game for both brothers and pays $4.75 to ship each game, how much can he spend on each game without spending more than $100? Write and solve an inequality for this situation. So Zachary has $2. He wants to buy these without spending more than $100. So think about what that means. And how are we going to change that into a math statement or using math symbols? So without spending more than, we want to think he can spend $100. He cannot spend over that. So he doesn't want to spend 101, 102, or 150 bucks. So he wants to spend less than or equal to 100. And then on the left side, over here, is going to be made up of how much he's actually spending, those games. So he has 2 brothers, so we're going to do 2 times something, right? Each of the games. And it's mentioned it's going to be the same game if you read the second statement. So we do not know the cost of each game. It says how much, so I'm going to put like brackets around here. How much can he spend on each game? So I'm going to call that my X. Each game is worth X. And it's $44.75 to ship each game. So adding the shipping cost plus the actual cost of the game, that's 1 game. And we have times 2 to make that 2 games. Several number of ways I can think of right away to solve this. So I'm going to divide both sides by 2. Notice my inequality stays the same. And I end up getting X is less than or equal to $45.25. So this means, I'm not going to write down the whole solution, this means that Zachary can spend $45.25 or less than that for each game. So think about all the solutions. He could spend 45 bucks, he could spend 40 bucks, he could spend 38 bucks, but he doesn't want to spend something like $49, $47, $53, things like that. That would be too much. Okay, so look at number 5. Again, a lot of ways that you could go about solving this. I'm going to distribute And 4/3 times 6x is going to be 8x. And 4/3 times 9 is going to be 12. Is 4. Subtract 12 on both sides. And then divide both sides by 8. And there is your solution. Number 6. The first thing I'm going to do is distribute this -2. Be careful with the sign. So I got -1/2. It's -2/4, but that reduces to 1/2. Minus 4 is greater than or equal to 5. Add 4 to both sides, so -1/2 x is greater than or equal to 9. And then I'm going to multiply both sides by -2, and that means x is going to be less than or equal to -18. Pay close attention to how I switched the symbol, or flipped it, or reversed it, or whatever they call it, and I end up with x is less than or equal to -18. Now we're going to look at creating and solving inequalities that could have variables on both sides. So let's take a look at the your turn down below. Page 76, we're on number 8. School band will sell pizzas to raise money for new uniforms. The supplier charges $100 plus $4 per pizza. The band members sell the pizzas for $7 each. Write and solve an inequality. Find out how many pizzas the band members will have to sell to make a profit. So we want to find how many pizzas. So I'm already going to mark this. This is my unknown. You can call that x or p or whatever variable you want to use. And we want to sell to make a profit. So think about what profit means. It means that when we buy the supplies from the supplier, we want to make more money than that, right? So we're spending some money getting the supplies, then we're going to in turn sell that to the community, the parents, students, and things at $7 each, and we want that to be more than how much we're actually paying. So let's look at the different parts of this. Think about how much are we going to spend on supplies. And then we have this thing called revenue. Revenue is how much money we're making. And don't worry about how the cost and stuff. Revenue is just, if I have a pizza and I'm selling it for $7, and let's say I sell 2 pizzas, I have a revenue of $14. Okay, so the supplier is going to charge $100 plus $4 per pizza. So $100 plus 4 times the number of pizzas, 4 times x. So that's the money I'm spending just to buy it, so I could use it as a fundraiser. So I want the money that I spend to be less than my revenue. I want my revenue to be more, right? If my revenue is higher, I'm making some profit. So my revenue is going to be $7 for every pizza that I sell. So 7x. Okay, let's go ahead and solve it. So subtract 4x on both sides. And I get 100 less than 3x. And when I divide both sides by 3, I get 33 1/3 is less than x. So think about what that means. I could also write it as x is greater than 33 1/3. So how many pizzas, if I read that question again, how many pizzas the band members will have to sell to make a profit? If they sell 33 pizzas, will they make a profit? Or if they sell 32 pizzas, will they make a profit? The question you need to ask yourself. I'm sorry, 34 pizzas. So 33 pizzas or 34 pizzas. Think about that because you can't really sell a third of a pizza. That's not how this works. So we're going to conclude that 34 pizzas must be sold. And if you think about it, if you sell 33 pizzas, that's not quite going to get us to our revenue higher than spending on the supplies. So you don't have a profit, right, if you're selling only 33. But you're really, really close. Okay, and that is it. Thank you so much for watching. Have a good day. Thank you.